Hello and welcome everybody to today's battery spotlight session. And I'm really happy that so many of you joined us again. And for those who joined the first time, let me briefly introduce you to this format. I hope that everybody can see the slides. And so, yeah, Simon, can you see the slides?
Yeah.
Perfect. All right. Yeah, we started this format now over 2 years ago with a simple goal. We wanted to help companies along the battery value chain to get visible with their information and their innovation, and to give them a chance to spark interest for their innovation with others, and also to help them connect with partners, and once they are connected, to start working together, so that this event can become one puzzle piece in transforming the individual battery ecosystems we have right now through all of Europe, and transform this individual ecosystem into one European-wide ecosystem. Let me quickly introduce myself. My name is Dr. Maximilian Wagner. I am the network manager of TraWeBa. TraWeBa is funded by the German government with a goal to connect companies along the whole battery value chain in Germany with each other, but also to help them reach the companies through all of Europe.
And also would like to welcome you from my side. I'm co-moderating the event together with Max. My name is Simon Voss. I'm the founder of Battery and the Battery Expedition, exploring the competence that we have in Europe on site with this little vehicle that you see there, or maybe have seen on LinkedIn. So also welcome from my side.
Yeah, and we are not only co-moderating this event together, we are also working on other things. And one of them is the event Battery Investors. And maybe, Simon, can you give us a short summary of what we are intending with this event?
Sure. So maybe the background story shared really quickly. So I traveled over Europe the last year and visited many companies, of which some of them are also presenting today, and explored the big potential that is out there. But what many of those companies also said, that we need investments. We need to scale our technology in order to really build the European ecosystem. So I sat down together with TraWeBa and the Walter Foundation and said, like, guys, can we do something about that? Can we set up an event where we invite companies as well as investors, and not just loosely invite them, but kind of pre-select potential matches with high potential, where we actually are convinced of that they will have a good basis for joint collaboration in order to scale their technology and really make a business out of this. Because this is what we actually need in Europe. We have the potential and the technology, but we have to bring it to scale now. And this event shall aid in that. So it's a low friction event, I would call it. It's on the 4th of May in Berlin. So it's good to reach, and it's only half a day. So if you're a startup or investor joining this event today, or a company that is also wanting to scale a certain product or what have you, please feel free to click on the link in the chat now and register yourself in order to attend it. And yeah, we would love to see many fruitful discussions coming out of this gathering there.
Yes, and it's not the only reason to travel to Berlin in the beginning of May. Just on the next day, we will host the TraWeBa Congress. Also at the same location, we will have the Battery Investors event the day before. And there we want to show and focus on the potential that networks can offer, and how you as a company can benefit from the networks we have already established. Thanks to our funding, both events will be for free. And yeah, especially for the TraWeBa Congress, you are all invited to join. The link you need to register for the event will be shared in the chat as well. And I think with this, enough about us. And let's move to the speakers, because we have a really interesting lineup. And yeah, just in brief, we will discussing today AI-powered testing platforms for energy systems, also battery materials recycled from black mass, and that actually is quite a difficult task. We will also discuss improved sealings for layers for batteries, and how X-ray can actually help to reduce scrap rates in battery production. And last but not least, how mass spectroscopy can help us to understand battery degradation. And with this, I think it's time to actually move to the first speaker. And Simon, please introduce him.
Yes, thank you, Max. So I would like to welcome Dennis Berner. He is CEO and founder of DigitLabs, and he's talking about something interesting, namely redefining the validation and testing for product approvals. So Dennis, without further ado, I think the stage is yours. You can share your screen and have 4 minutes to pitch. And of course, we'll after that open up the Q&A for everyone in the room here.
Perfect. Let me share my screen quickly. Should work, I hope. So hello everyone. My name is. You can see it?
Yeah, it's perfect.
Okay, perfect. Yeah. Hello everyone. My name is Dennis Berner, CEO and founder of DigitLabs, and responsible for the European and MENA market at the moment. And today I would like to introduce you to TestForge, which is our end-to-end component testing platform to make what was formerly purely Excel into the, let's say, the modern century. So this is what we try to do. In general, was just quickly I go through it because it's a complex topic, as everyone who's involved in testing knows. Our mission was to streamline and unify component testing, from finding qualified testing partners to schedulers to real-time tracking, logistics, and reporting. So having everything in a streamlined process. And mainly because what we figured in many years of being in the validation scene, that this is a lot of overhead involved. All parties have their own project managers, test managers, people involved for coordination. Whenever things are not working as intended, it takes a lot of time to basically untangle the orchestration processes between multiple partners that are involved. And this is basically where, in our calculation, up to 37% of costs are hidden when it comes to full-blown test campaigns. And this is basically where we started from, streamlining everything, bringing everything to one platform, because we want to make it frictionless. We want to make it easy. We want to bring the orchestration in the hand of the component owner to make basically development processes and times more easy and shorter. This is the main intention of our platform. How we do this is basically that we bring all relevant parties to the platform itself. So it's not like a distributed network from email postbox, from mobile phones, from whoever's involved. Has to be coordinated, let's say, in separate silos. What we are doing is we are enabling manufacturers or developers to have their own account together with testing laboratories as some sort of entity in our SaaS platform. And we also think about extending this furthermore into engineering services and logistics this year when it comes to bringing all relevant party in this room together. And the main intention is that we bring the full responsibility and control for manufacturers back to them, that they don't have to rely fully on the external parties. We want to make sure that they're in full charge of being able to specify what their product or component is about and what they would like to have tested. And then furthermore, bringing this or requesting from the associated testing laboratories what test can be done by whom. So it is not like in the traditional sense where I ask one test laboratory and they are asking each other who has a capacity to test something. Now the ownership is basically directly at the manufacturer, getting only the feedback from testing laboratories who are also able to conduct the tests. So the coordination is back to the product owner, more or less. So, and this is also where we see there's a lot of waste in the traditional process where you always asked multiple times the same tenants for certain things, and then they are asking each other to give a full-blown offer. And this is something we want to get control back to basically the one who's owning the component. Maybe quickly, so we have roughly, as I just said, a few modules inside of our platform. So we have a test marketplace and in-house testing, so you can orchestrate basically internal testing capacity, but whenever you need external one, you can do this as well. You reach out to the testing platform or the testing marketplace. We have a real-time planner where you can schedule everything dynamically. You can also request moving things back and forth whenever things are not working as intended. We have semi-automated test reports. We call it semi-automated because we are further implementing AI process solutions from our other SaaS platform, Addict.AI, which is full-blown AI agentic ready. And we will implement this furthermore in our TestForge platform in the future. And on top, you have a test management system. So you're basically having all your test data in full control. We are urging most of the suppliers and testers to link their own cloud storage so that we are not taking care of, you don't know where your data is. And as soon as you disconnect from the TestForge, you can basically rely that your product and your data, which was very costly, is still in your ownership. We also have some gimmicks inside. We have a canalizer, more or less. You can easily convert BLF files online. You just upload the log file and then you're converting this. And we will also work with the first partners who are interested in this to extend this further to make online analytics also possible with, let's say, proprietary formats like the BLF format here in this case. And in the future, we will also extend more on these one-off shops for logistics and recycling so that you really have this end-to-end solution, basically from specifying and then having your product tested, reported, and completely also the chain of recycled if needed. And just quickly, as one of my last slides here, it is simply as you're describing this in 4 steps. So you're specifying your product, you're creating your test campaign and bundles, you are requesting this on the marketplace or doing this in-house, and then you're basically more or less ready to start testing. So this is, and we are eager to optimize this further and further so that it's really getting as fast as possible to get the first offers in. And like I said in the initial, let's say, slide, it is because we believe testing is not just for fun. It is a valuable asset. It generates data which you want to rely on in future projects. And we want to make sure that what can be saved in modern world where agentic AI is present, where SaaS solutions are very mature, that you don't waste time on manual processes.
Okay.
I'm pretty much on time.
You're done, right? Just wanted to make sure. So, Dennis, thank you very much for the pitch. Very interesting. So, as I understand, you're kind of building a platform, and you just outlined the process from a customer perspective, right? I could imagine that there are a couple of interested people now, also from a supplier perspective, offering their services. So, could you explain what the accreditation process would look like? So how can one participate on your platform?
Yeah, so how it's currently implemented is that you can ask for engineering on demand. This is how we call it in the platform. So basically, what we want to do is we want to work with external companies who are specialized in certain areas. And whenever, because we are giving back the ownership to the product owner, and in many industry situations, I saw this that I did it myself in my VW times, but that you have external support with certain expertise to support you with quality control or whatever. And what we want to do is that we partner with as many as possible to give them also the chance to still contribute as they did before, but more in the control of the manufacturer or developer, that they say, here in this case, I need a certain type of skill which I don't have. And now I'm asking specifically for that, let's say the companies that are involved, and I can onboard specifically for certain tests or for the entire campaign, so that the need to know principle is still in place.
Mm. What is the time frame of this onboarding, generally speaking? So just having a good idea on how to work with you. Yes.
So we are currently in the phase that we say, okay, we need now as many as possible to join, because it's a network Basically, it's a marketplace, so you need basically the institutes, the engineering services, but also the manufacturers who wants to have their component tested. It's not limited to batteries, by the way. You can basically specify wherever testing is required or homologation tests are required. You can basically specify this. And then what we want to make sure is that as many as possible join, especially from the testing capacity side, so that whoever joins from the customer side gets also, let's say, the amount of offers they want to have.
Yeah. Portfolio they can choose from.
Yes.
Okay, good, understood. So I think then I'd like to thank you for your pitch. If there are any other questions and the audience has warmed up a little bit, please state them in the chat to Dennis, and Dennis, you can have a look and maybe answer it there directly. Otherwise, we will likely also have a little bit of time after the event to briefly catch up the one or the other conversation. And with that, again, thank you, Dennis. And I would like to hand over the mic to my co-moderator, Max. Stage is yours.
Yeah, thank you. And we will also switch the topic from testing now to recycling. And I mean, we all know recycling is important, first for the environment, but also for the resilience we have we need for a European battery ecosystem. And I'm really happy to introduce Marie, the COO of Pure Batteries. And what they are doing is they produce battery-grade materials from black mass again. So the perfect idea of the recycling, so that we can use the black mass to produce new batteries, which is very difficult because you need a really high purity. But I think what the problems are and how they solve these problems, Marie can explain way better than I. So Marie, I'm really happy you are here, and the stage is yours.
Thank you, Maximilian. I will just share my screen quickly. Okay, you can see the screen?
Yes.
Perfect. Thank you. Thank you, everyone. Good afternoon. I am Cyprien, like Maximilian mentioned. I'm the COO for Pure Battery Technologies. So I'm excited to be here, and I'll jump straight into it. So as we know, we all have sorry, the screen is not moving. Let's start with technical things straight away, like that will be out of the way. Here we go. So the European battery is growing. That's not a secret for anyone here, but it is still missing the midstream capacity. Traditionally, that was due to the investment cost and the operating cost of having such midstream in Europe, as well as the difficulty to obtain the permits, considering the technologies that were available. So as Maximilian mentioned, that actually is posing a great problem for Europe, which is really exposing it in terms of resilience. We've built up the demand, but we can't guarantee the supply. And ultimately, it is blocking that full circularity to enable the recycled material to come back into the supply chain. So this is the gap that PBT is aiming to fill. So we really want to create a new low carbon pathway for raw material to enter the European supply chain, and also a new pathway for recycled material to re-enter that same supply chain. And we want to do that by refining locally, building up that resilience with a low carbon footprint and being cost competitive, because the reality is that if we're not cost competitive, there is no way we can sustain it in Europe. So we do have to do it differently to be able to meet this objective. So what do we propose is to actually use our technology to refine MHP and black mass directly into pCAM in Europe. So pCAM is the precursor to cathode active material. It's one of the key elements in the cathode that is a key driver to its quality, cost, and performance. PBT was founded in Australia in 2017 based on some technology that was developed at the University of Queensland. And we've developed and patented both the cell and CL technologies that enable us to produce pCAM directly from MHP and recycled black mass. So let me tell you a bit more about these technologies. The cell and CL are really changing the way we make pCAM. A very common route until now is to use solvent extraction, which means that we're refining each of the metal individually, separating them, crystallizing them, turning them into pure salts that then we mix back together to make the pCAM. That requires a lot of steps and a lot of energy. Our technologies enable us to actually keep the metal together and to produce the pCAM directly without making the salt intermediates. The other key differentiator is that we can actually process both MHP, which is a mine intermediate, the mixed hydroxide precipitate, and black mass, the recycled material that comes from end-of-life battery, together or separately through the same processing line. So we don't need separated plant to deal with them. So we end up with a much simpler process, meaning less equipment, less energy, less reagents. We don't need solvent. And so that ends up with a much lower carbon footprint and a lower cost, which makes it competitive and viable in Europe. And that's where we plan to use it. So we do have, PBT has a refinery in Hagen in Germany that is already producing nickel product. We've got a very talented and expert workforce that has been producing nickel product for decades. We've been able to retrofit equipment in the refinery to prove at industrial scale our technologies. We've actually processed some real MHP and some real black mass, a lot of them, and we've made some very pretty pCAM, as you can see in the top right, that is performing compared to benchmark. So we have planned a full project in this refinery, basically a full expansion to become the first direct-to-pCAM refinery from both black mass and MHP, where we can produce 10,000 tons of product in metal. The technology is proven. It is actually fully permitted. The engineering is ready to move into execution, and we're running through the final round of funding so that we can actually make it happen and get the circularity that we need in Europe. So that's where we're at. Thank you. And I would welcome any interest in our projects. We are, like I said, running through the last round of funding, and we're also growing and looking at some expansion projects in other places of Europe, Indonesia, and US. So any interest would be, I would be happy to discuss. Thank you.
Thank you very much, Marianne. Perfectly on time. Yeah, so if there are questions, you can also always raise your hand and unmute your microphone, ask your question directly to Marie, or put them in the chat. And maybe, Marie, let me start with a chemical question. You mentioned that no solvent is involved. And from my study as chemist, I know solvent has a really important part. It helps getting in contact all the reactants and get the efficiency high. And maybe could you comment on the efficiency you get if you're taking away the solvent, and also maybe comment on which metals is your process including?
Very good point, actually, Maximilian. We are focusing on NMC batteries, so nickel, manganese, cobalt, which is one of the key chemistry that is being used in electric vehicles. We are achieving over 97% recovery of the metals, of the nickel, manganese, and cobalt that we have in both MHP and recycled black mass.
Thank you. That's impressive.
That's
also
a very large group of
material
material that we can put back into the supply chain.
Yeah. All right. Before I come to my second question, Leonardo has a question.
Yes. Thank you very much for your presentation. I like it so much. And I'd like to ask you a question. So is it just selected to NMC, or does it go with other chemistries?
So at the moment, we are focusing on the NMC chemistry. We can produce pCAM that can be used for LMNO batteries as well, the lithium manganese oxide batteries. But our focus for the recycled stream as feedstock is recycled black mass from NMC chemistry.
Okay. Thank you very much. Cheers.
Yeah, I have to say, 97% is impressive. And also, as I mentioned, the recycling is really important, especially for the resilience. Could you give us some I'm not sure if these amounts are, if this question is even possible to answer, but maybe could you give us some realistic amounts what we could recycle, like from the technical view and also from economical view in the next, let's say, 5 years?
In terms of volume of metal, is that what you mean?
Yes, exactly. So the idea of my question is like, how do we still need to mine the materials, or could we, in principle, get a closed loop within the European ecosystem with the materials, like considering 97%?
So it's a timing question. The reality is that recycling of black mass is only becoming available once there is black mass becoming available, which is coming when a battery comes to the end of its life. So you've got a delay between when we make the battery and when it actually comes back to into the supply chain. And while this comes back, that demand is usually growing. So by the time the material has come to an end of life and that we can recycle it, the demand has grown. So there will always need to be a supplementing of a raw material, but the amount that can come from recycling is going to grow more and more over time as we're shifting more and more into the use of battery across many uses, and that these batteries come to end of life and come back into the supply chain.
All right, yeah, thank you. And maybe also, unfortunately, we have to move already to the next speaker. So thank
you very much.
And I'm heading over to Simon again.
Thank you, Max, for handing over. So yeah, you said moving, and I moved to Austria for a couple of days during the battery expedition, and actually went to the innovation center our next speaker is coming from, and that is Borealis, who delivers pouch foil polymers made in Europe. And with that, I would like to welcome Jevgenia Lakissova-Karagkouni, who's new business development manager at Borealis, and she will actually talk about this polymer that I just mentioned and the making of it and what it actually means for local supply chain security, which is becoming more and more important nowadays. So, Jevgenia, without further ado, stage is yours. Screen is already shared. You're free to go.
Thank you for the introduction, Simon. It was a pleasure actually to have you over in our innovation center and have the conversation, and to participate in this value chain is a great pleasure. It's a different type of industry for Borealis. It's a developing industry, and we're happy to support. In general, I think the flavor of Borealis being a participant in this type of value chain is different because we are a well-established industrial player. We are one of the strongest polyolefin producers in Europe, with major operations, major footprint, innovation in Europe. We produce and distribute polyolefins, so polyethylene and polypropylene mainly, but not only in Europe, also globally. We have joint ventures across the globe. And actually a very innovative company as such. So in Austria, I think we're #1 by patent filings per year, and we keep innovating and pushing for various applications where polyolefins can add value. Speaking of which, we are not new to neither energy sector nor mobility, or specifically e-mobility. When we think of the batteries for mobility and electric cars, we actually have a wide established portfolio of commercial products, polypropylenes, reinforced materials mainly, that can support the very demanding under the hood applications for e-vehicles. We've been in that for a decade, I suppose, for e-mobility applications, and we know the demands of the industry as such. But what we are constantly doing, we are pushing the limit for new applications. This is what the new business development is about. And one of the programs we are running in this unit is the so-called electrification program. This is where we try to bring our knowledge and define the value add applications where polyolefinic materials can be of value. So one of those items in the electrification program, the one we have the pleasure of hosting you in our innovation center to introduce, was the packaging material that is basically used in the pouch cell packaging. So that's one pouch cell. I don't know if you can see it with the blur, that was produced with one of the partners on this journey, a Spanish company, 𝗕ጵ𝘁𝘁𝗃𝗁𝘁. What we are offering is the material that can be used in the laminate that keeps the cell together. So, and I will come to this in a moment. Actually, typical pouch cell packaging is a multi-layer structure. So what you see is an end product, but what's a critical element where Borealis can add value and does add value is the inner sealing layer. Maybe it doesn't come across very clearly, and maybe it doesn't look very impressive, but it's actually a thin 80 microns casted polypropylene film that essentially prevents any leaking in the pouch cell due to its sealing strength. And the difficulty of working in this industry is that we're a few steps down the value chain, but at the same time, if our polypropylene formulation fails, then the cell will fail, then the sealing properties will not be achieved, and it leads then to a safety issue, essentially. So that's the product I'm pitching today, the polypropylene for creating this inner sealing layer within the pouch cell laminate. And since it's a pitch, I wanted to maybe say a few words also on why it's important to bring this product to the European market. I mean, yes, we are all aware of the Critical Raw Material Act, or the Battery Passport is coming into force next year. Now, polypropylene is not a critical raw material. There is supply, but what we're seeing with geopolitical events, the supply of essential elements of the battery, of the cell, can become a risk for scaling up operations. So having this type of materials available locally is very important. It not only improves the lead times in the operations, but it's an essential part of de-risking the scale-up strategy. Currently, this type of products, both actually film for the sealing layer as well as the laminates, are imported. There is no scaled production in Europe, and this can become a bottleneck. When we interact with the cell producers at the industry events, they immediately flag this as a critical topic. They need the packaging material. And we are here to, not as a startup, we are a reliable, established industrial player with decades of innovation and competence, specifically in the polymer design. We can support stable supply agreements. So we're here and having quite a solid track record. What I think is important for the battery industry, I mean, packaging is maybe one of the, let's say, lower priority topics on the mind when you think about active material in a cell. Of course, that's critical. This is not where we know the supply is constrained. And that also means that the battery producers, cell producers, are not necessarily networked or connected in the value chain of packaging material. And this is where Borealis can add value. We actually bring partners on board that are also working in this application and are interested to play. And last but not least, packaging may seem like, again, a smaller thing, but actually the strength of Borealis also is that we have a strong portfolio in renewable polyolefins. So it means that basically half of this laminate structure can be produced with a polypropylene that has renewable sources. So it essentially could help the cell producers and then OEMs down the stream to reduce the CO2 footprint of the battery solution.
Okay, Jevgenia, thank you very much. I think this is the end of your pitch, right?
Correct.
Good, because I really value your contribution, because also on my visit at your facility, I really get to know how intertwined everything is and how dependent we are suddenly if we are not aware of all these interdependencies that are out there, right? And I can tell you from my research from the past years that this is not a simple foil, the pouch cell foil. Back in the days, you called a pouch cell a coffee bag cell because the material of a coffee bag, like you can buy coffee in, is quite similar. But I can tell you, no, it's not, because the chemical resistance, etc., the sealing strength that Jevgenia also was referring to, that is something that has to be engineered. And yeah, so this is the importance, and I think you outlined this very well. My question to you is, this is still just a polymer that is one component of the pouch cell, right? Can you sketch out really quick what it means also to build a full pouch cell in Europe? So what are the partners? Do we have everything that we need in order to use your polymers to build a full European-made pouch cell?
So are you talking about the packaging material, or are you talking about all the active components as well?
Well, in this case, I'm talking about building the battery pouch cell.
Yeah, well, of course, there are a lot of developments, and it also depends on the chemistry you are looking at. But we are all aware that the critical raw materials are the bottleneck. This is why recycling and scaling up recycling is so important. When it comes to the packaging piece, this is where the core competences of Borealis would be. We know that there are players that are actively investing in this area. So I think come a year or a year and a half, there will be a possibility for scaled up production for supplying these materials. And it's also about the market pull and uncertainty. To be honest, industrial players like ourselves have to be very careful when committing investments into that, because of course it only makes sense if the market demand follows. If the cell production steps are delayed, then it means that we are basically incurring losses also by keeping the investment on that. And I'm sure we are not alone in that, you know, so having kind of certainty on the demand pool is important. But I know purely from the network that there is a lot of movement and focus in this area. So when it comes to also the chemistry, there are a lot of developments happening in the solid state area, for example. But again, it's a question of scaling timely and bringing it to the market, because there is a lot that is already proven and working on an R&D level, but being ready for industrialization is a different thing. And this is where the stable supply of all the components becomes a topic.
Okay, so I understand. We need the customer uptake. Final question to you from the audience, from Tejas. He's asking, what about the long-term durability of pouch cells in comparison to other formats?
Yeah, well, there are tests, of course, designed for that. That's actually something that is going on for us currently. These are the type of tests we outsource. We work with recognized testing institutions to do the aging testing after the electrolyte exposure, for example, to exactly prove that there is reliability and needed quality. The typical lifetime of a cell is 10 to 15 years. This is why formulating the polypropylene to serve this requirement is critical. There are also laminates for example, consumer electronics pouch cells, and there the lifetime is much lower. So that's why in special facilities, generally the design of this testing is such that there is electrolyte exposure and then there is accelerated aging to prove exactly that.
Yeah, thank you for this assessment. And thank you for your pitch, of course. So I think the time is pressuring us to move on to our next speaker. And Max, I would like to ask you to introduce.
Yeah, thank you very much. If you consider a battery, it mostly is just a black box. And if you have ways to see what happens inside of that black box, that is very important. And mass spectroscopy could be one of the ways to actually see what is happening inside and give us really valuable information about degradation processes happening in the cell. And yeah, that can of course be really valuable information for very lot of different questions and then also optimization of the cell. And yeah, with this, I'm really happy to introduce Mikhail Gerasimov, CEO of BatteryGas Analytics, who are doing exactly this, using In-Operando electrochemical mass spectroscopy to get such information. And Mikhail, I'm really happy that you made it here, and the floor is yours.
Thank you very much. I hope you can hear me well and see my screen.
Perfectly. And I can also see your screen, so you're ready.
Please say again, how much time do I have?
4 minutes.
4 minutes should be fine. Perfect. Okay, thank you very much. And ladies and gentlemen, hello to the pitch of BatteryGas Analytics, and thank you very much, Maximilian, for the kind introduction of us. Together with my two colleagues, Luca Zimmermann and 𝗕hiểu έχει𝘃𝗃𝗁𝗵𝘁, I'm going to represent our new startup, which is currently forming. And Maximilian said it very well. It's about the analysis of the black box of the battery. Let's dive quickly into it. So basically, you all know the basic vision which we have and the reason why we're here together. No? It's about to make sure that we trust into the new technologies and make sure that we get new knowledge with them and make them technologies which are used very well in the industry today. So you know the volatile situations which we have currently in the world, and we do not want to have any volatile situations in terms of safety of batteries. Therefore, we decided to have a look at our batteries and see how we can improve them, basically. And this is what we're going to do. And with our measurement service, we want to make the invisible visible. And with that, I would like to switch to some problems which you all know, and the problems which we also know and want to tackle with that. The first one is the loss of capacity. You all know that if you buy a new cell phone, after roughly 2 years, it only has capacity left of maybe 90%, which is not very nice. What is the reason for that? Well, it's the chemical reactions which we have inside the cell. The chemical reactions lead to capacity loss by the consumption of lithium ions. Then we have the swelling of the battery, also a phenomenon which I hope you don't experience too much. I had that experience with my laptop where it got thicker like 1.2 times from the original thickness due to the gases which are coming out, again, from chemical reactions. And third, which I hope nobody experienced in our life and will never, is the thermal runaway, which means we have kind of an explosion of the battery. And this again is caused by chemical reactions. You can see all three are basically connected with each other by those chemical reactions. And this is the reason why we decided to take them and analyze them. But how we're going to do it? Well, we saw we have the swelling, and that means we have gases at every single step of our degradation of the battery, whether it's capacity, swelling, or the thermal runaway. And this is exactly what we're looking at. So we're looking at the gases and try to catch them, analyze them. And this is our mass spectroscopy, which we have. So our methodology is nothing else than just capture the gases In-Operando, and this is something completely new, and also with free availability to discharge the battery in parallel, and also influence the battery's temperature inside. So what we're offering as a service is you give us the charging protocol, which you have, for instance, fast charging for some applications or high temperature applications. And we are able to capture the gases which are evolving within your cells and generate results, what is happening inside. I'll give you a quick overview how it works. It's nothing else than a special cell, which we have together with our partner ELCell, and we combine it together in a measurement stand, which is able to capture those gases, as I said, In-Operando live with our mass spectroscopy system. So that means that at every single time step, which we're looking at, we have the exact amount of gases of all types of gases live, which is quite nice. And it allows us to analyze them at every single time step of your protocol. These measurements have already been published at some points, and we're also currently in the process of getting the patent for our measurement stand to be able to offer the service exclusively to you. What kind of services do we want to offer? Well, there are 3 levels, basically. You can send us materials. They can be secret, so we do not need to know what kind of materials you send us, and we just measure them. We can also analyze the gases which we have here, if you tell us what materials we have, and also simulate them, which is the last layer of our company. So basically simulate what is happening inside. For instance, SCI changes, at what temperature do they have? Maybe with another additive, it changes again. So you can see, after evaluating it in the simulation, we can come back to the measurements then with, for instance, new additives and test the batteries again. So what is the team beyond our company? As I mentioned, Richard and Luca, they are both my co-founders with them. One guy, the Richard, is looking at the simulation stuff, and Luca for the measurements then, and me being the head of our company. And we're currently, I guess we're like a lot of people, looking for investors, potential partners to investigate it even more and to run, basically run the services now. So please feel free to contact me at any time. And if you have any questions, please don't hesitate to ask them.
Thank you very much. And I heard there actually is an interesting event suiting your needs.
Yes, I hope that.
No, but to my first question, very interesting. But first question, how is it about long time degradations? So things happening really slowly over a long time. And let's assume that they produce gases.
Mm-hmm.
Can you see them? Can you measure them?
Good question. Theoretically, yes, we can do that. With some new cells, which we're developing together with our partners, we are trying to evaluate the long-term degradation. The problem with the current cells is that at some point, the electrolyte is just going away because of our measurement systems set up there, which means we're currently focusing more on short-term degradation. So, for instance, we had companies which came to us and said, we are charging buses, and for bus charging, we have a serial of 5C, which is a lot of stress for the battery. And we want to see what happens there with the gases. And do they change maybe if it's outside minus 20 degrees in some countries or plus 30? And this is something we're currently looking at. So the quick events, the short-term events, and how it stresses the battery.
All right, yeah. And maybe second question about the limitations. Obviously, you need some gas involvement included in the reaction. Do you know, are there some processes you can't see but are really important as well? But also, maybe what are the most important processes that you can see?
Mm-hmm. That's a very good question. So as you could see in my introduction, we are focusing on the gases evolving from the chemical reactions, which means if we don't have any gases, of course, our measurement device won't be able to measure them. That makes sense, right? The good thing is that we are able to not only measure the gases, but also hand over with our test device the materials afterwards to other companies. For instance, once we did XPS measurements after an analysis of gases to see, did it really nothing happen? Because the gas analysis showed nothing happened. The answer was no, really nothing happened there. But we are able to collaborate also with other laboratories there. So we are kind of like a service offering a more look inside our black box using gases. So gases is really our focus there.
All right, thank you. And then one last quick question from the audience. How do you handle your own safety doing analysis?
Oh, very, very good question. It's quite easy. The cells are very small. So as I said, you can send us just the materials. That's completely enough. And we're talking about coin cells from the size. So we're not talking about really big cells. It's rather to get an understanding of the chemistry inside, not the energy, how much is coming out and so on. And thus, with such small cells, there's the problem with the safety.
All right, Mikhail, thank you very much.
You're welcome. Thank you very much for offering the slot here for us.
And I think we are staying, or the next pitch is suiting quite well. But maybe Simon, you visited the facility there as well, and so you have the honor to introduce our last speaker for today.
And I can say that it's an honor. It was actually the last meeting of last year. So, Bernhard, I remember us sitting on the 19th of December, I think, right before Christmas.
17th, actually, to be accurate.
Was it 20th?
17.
Okay. Yeah, but we were already pretty done for the year, but it was nevertheless extremely exciting to visit your place because you gave me some insights on the inside of a battery cell by means of your 3D inspection equipment and that inline. So this is really something that is changing our industry and levering big potential. But I think you're better at explaining this. And I will share some links for those who want to see some more pictures after the show. But now the stage is yours. And the next 4 minutes are yours.
Thank you so much. Thank you very much, Simon. So hello everyone. Thank you for the opportunity to present today. So my name is Bernhard Mürkens. I'm head of VCbattery at VConsult. Today I will show you how scaling battery production requires scaling quality inspection. So what does it mean? At Gigafactory scale, so we're talking about 100 million of cells. And even a small defect rate, that means about 1 million defect cells a year. So you can imagine then small defects becomes a real massive economic loss. Keep this in mind for the stage. And what does it mean? Most critical defects, however, are inside the cell. So here are a lot of X-ray images in 3D. Normally, these defects are not visible with standard inline inspection systems. Simply not possible. So when you then look into what's today done, electrical testing is just producing indirect results. An external inspection with cameras is only the surface showing. A post-process analysis gives you always only a delayed feedback. So what's important is there's no direct link between a process parameter and some internal defect. So you really have to see that this is a gap. And that's where high-speed CT comes into place. This is high-speed CT for inspection in production. So it's 20 to 50 times faster than conventional CT. It's really designed for the industrial environments, and it's able to detect the defects automatically. And what you see here then, it's really a direct correlation between process parameters and internal defects. So what does it mean? What's the impact? So when we have a ramp up or something like this, how is it today? So today you have a delayed analyze, you have a sampling-based inspection, and also the root cause is unclear. When you now use inline CT, you have an immediate internal feedback, you have a full internal visibility, and then you have a direct process correlation you can rely on. So it's from a delayed analysis to an immediate production process monitoring with internal feedback. So, and for sure, yield is here the largest lever of value. So 1% yield improvement, and you all know the metrics, you can calculate about 6 to 7 million euro savings annually. And this is done by reducing scrap, a faster production ramp up, and stabilizing your processes. And this is just one of the many use cases where people can save money utilizing this technology. So at the end, it's an inspection paradigm shift, like Simon mentioned a little bit in the beginning. It's from external late analysis with limited insights to an internal visibility, a real defect detection, and a direct process feedback. So it's everything else than before. And that means you come from a black box production into a data-driven manufacturing. And of course, you can integrate this into the line. So either near to the line for process development, you make an inline integration for critical process steps, and definitely you can scale it to your inspection strategies. So the message is it's a flexible deployment depending on the requirements on the factory floor. So when you then look into the future, of course, you know that battery production is getting even more complex. So higher energy densities, more materials, new cell formats, and the factories are getting bigger. So what they all need is more inside views. And this is where high-speed CT is getting into. We are providing the data to monitor the process. So you come away from this not knowing to the knowing, so that the high-speed CT then transforms batteries from a black box into real production data. And you see a lot of examples I just show you here on the screen. So thank you. Ready to take questions?
For the audience, please prepare your questions. I'm waiting for them. There's already one. Do you deliver turnkey container with dedicated instrumentation directly on Gigafactory site?
Well, it's a turnkey solution. So in a nutshell, yes, we do. The key element is when we talk to the big gigafactories, it's about then how are the cells coming to our machines, and then it's about automation integration to our agnostic machine to coming cells in trays or on pucks. It doesn't matter for us.
Yeah, and I think we also covered it during my visit. You also explained this a little bit more in depth. So yeah, please be referred to the recording if we don't find the time to explain it here in detail now for understandability. I also have a question, Bernhard. I think to reflect on the technological advancement that you're pushing forward here. Why was this not done before? Like, why was there no one putting an inline CT, 3D CT inside there? Because there's a key enabling factor that you deliver.
Yeah, the key message is you have seen numbers where 20, 50, some customers are telling us we are 100 times faster than the next best technology. So in the past, this technology was only a lab scale equipment on the lab, on the F1A analysis floor. And we integrated next generation high-speed image chain stacks on the X-ray source side, which having 30 times more photons than any other source before. We're integrating photon counting detectors on the other side with frame rates which are 20, 30, 50 times faster than the current using models. And when you generate this together, then you can screen a cell instead of minutes in seconds. So now we are screening a 4680 cell in 10 seconds or down to 5 seconds, one full 4680 cell. And then the rest is then, of course, high-speed reconstruction. We are masters in high-performance computing now, and then making the analyzing part afterwards.
Also, maybe an insight I get us from, you're not coming from the engineering side initially, you came from the software side, right? So
as a group, VConsult as a group, we started on the imaging side, analyzing X-ray images. So, and then companies ask us, can you provide turnkey solutions? So, and then we integrate the engineering and the automation. So now a customer, as the first question was, you can ask us for a turnkey solution and you will get a turnkey solution.
So Bernhard, thank you very much for giving your insights. And yeah, please feel free to reach out to them if you want to know more. And I think with this, Max, we are at the end of our event again. Once more, from my side, thank you for all the participants that joined the call, for all the speakers that shared the competences they deliver to our industry. And if there's anything, yeah, we will stay here a couple of minutes more. And of course, seeing forward to see you next time. That's from my side, but Max, maybe you also have some final words.
Yeah, also from my side, thank you very much. Thank you for the speakers. Thank you for the participants making this event possible. And of course, please, if you're interested, join our monthly battery spotlight session. The next one will be April 23rd on 4:30, same time as always. So yeah, you can find the registration link already in the chat. And maybe the last important thing, if you want to present your company or your startup, then you can also reach out to us and tell us what you can do. And we will reserve a spot for you so that you can present your innovation in one of the next sessions. And as I mentioned, we do this every month. So we are pretty sure we will find a spot for you. And yeah, so with this, I wish you all a really pleasant evening and looking forward to seeing you all again next month. And yeah, have a nice evening.
Thank you very much.
Bye-bye.
Thanks, bye-bye, guys.
Bye.
Thanks to everyone.